Uh, in Chapter 9, we will cover the subprograms. And subprograms has different names. It can be called subprograms or subroutines or functions or procedures or packages, different names for this concept. So we will be able to introduce the fundamental of these subprograms, their design issues, how we reference the local variables, talk about local reference environments and parameter passing, and also calling these subprograms indirectly. And we're going to cover the design issues for functions and talk about overloaded subprograms and generic subprograms. And then we're going to talk about defined overloaded operators and closures and coroutines. So we're going to start first to introduce this concept of subprograms, which falls under two fundamental abstraction facilities. Those are called process abstraction and data abstraction. The word abstraction itself refers to the act of hiding the details and showing the main picture or the main thing. So the process abstraction refers to the implementation, while data abstraction refers to the details of the data shown on the programs. So, for example, if you would like to see the difference between data abstraction and process abstraction in this regard, you can say that in the process abstraction, saying that process will be done without saying how it will be done. And also this coming from old and first programming languages that were developed back in the 50s and 60s, as old as the first programming languages. So functions and subprograms, they have this facility, which is process abstraction. In data abstraction, like saying that data has certain different properties without saying that how this data is represented. So the properties themselves are specified in terms of operations, which could be any mathematical operation that happens during the process abstraction. But in general, both process abstraction and data abstraction is hiding the details and showing the big picture of how it doesn't say, like, it doesn't show that how this process can be done or should be done, or the details or the procedures or the instructions inside these processes. So, so abstraction is a method of hiding the implementation details and showing only the functionality. So it provides guidelines to build a standard product. The guidelines, like the instruction or the guidelines, but no details on how specifically this operation can be accomplished. For example, you know how to you know how a car look like and how to drive a car, but you don't know to build a car, or you know how to fix it. You don't know how to fix it, but you know how to operate the car, to drive it. So these two examples of abstraction and interface, like can be seen in these two in this function called calculate area, for example, which has a lot of details. This calculate area could be extended to calculate area of what? Area of circle or area of rectangle. But the general thing, you know, that calculate area, you know that there is an area and that area need to be calculated. But what is this area? Is the area of a circle or a rectangle or a triangle or what? So no details that is given on this regard. So the fundamental of subprograms, in each subprogram has a single entry point. So this subprograms, of course, it has an entry point, like a point where it receives this input and values. And the calling program is suspended during execution of the called subprograms. Called subprograms means subprograms like functions or procedures that are called or executed by another program. So the calling program is execution is freezed or suspending during the call of these subprograms. Or control always return to the caller when the call program's execution terminates. That means if you have two functions, one of them calls another, like in C or C++, for example. If you have the main function calls another function to do specific operation, so after this function that does a specific operation, like for example a function that calculates the area, for example, after it terminates, then the control goes back to the caller, which in this case the main function. So these are fundamentals understanding of the relationship between the caller and the called function. So we have to understand the difference between called and caller. The called is a subprogram that calls another subprogram, such that the first one execute the second one. It refers to these two terms, caller and calling, executor and executing. So the executor is the caller, the function that calls or executes the other function. So for example, if I have this in C++, let us assume that I have this function that this function here called the main function, which execute calculate area, for example, here. All right. So in this case, I would say there is a function called calculate area, which its job is to calculate an area, and this is the main function that executes this function. That means this is a subprograms, okay, executed by the main function. In this case, this is called the called function, and this is a caller. So main is a caller, and this is called, the called. So main is executor, and this is executed by this. But in our example, we talk about two different subprograms, because here in main is not considered as a program. It's considered the mother of other subprograms. So in this figure, you can see that this is a call graph of the main function, because here, if the main is a function that calls other, I have, for example, other functions or subprograms. One is called foo, solve, ones, count. Each one has a specific job to do. And if you look at this, you will see that ones is called by solve, and count is called by two subprograms, by foo and by solve, while main is calling these two, foo and solve. So in the end, after this one terminates, the control goes back to solve. And here, after this one terminates, the control goes back to solve and goes back to foo. And these both two subprograms, when the control finishes here, then the control, after the execution finishes here, the control goes back to this main function here. So it's actually a bottom-up execution process. Once called function finishing processing, the control goes back to the called function, and so on until all function executes and finishes. The specific definition that we need to explain here, like a subprogram definition. What is a subprogram definition? A subprogram definition describes the interface to and the actions of the subprogram abstraction. So actually the subprogram definition is the writing of the subprogram's code. In Python, for example, function definition are executable. So when you define a function, you write a function, it is written in executable manner. Some other languages, they are not executable, like a source code that need to be executed using a specific procedure or a specific processing, putting a semicolon, putting and, putting add, clicking on run, clicking on execute. There is a different procedure to execute these subprogram definitions. In Ruby, a function definition can appear either in or outside a class definition. So if it is outside the class, then they are methods of the object. So they can be called without an object like a function. In Lua programming language, all functions are anonymous. That they can be executed randomly without having a specific reference to them. It's called anonymous. So a subprogram call is an explicit request that a subprogram be executed. Simply, when you call a subprogram, that means you want this subprogram to be executed. A subprogram header, the header of the subprogram, is the first part of the definition. So we have some examples here. We'll show you in a minute. So a header is the first part or the first line of the subprogram, including the name, if there are some parameters, like also include the parameter profile. Including parameter profile, that means parameter names, parameter type, parameters, the list of different parameters, their order, and their protocols. That means the protocol of subprogram parameter profile. This is what kind of environment these parameters have. Like, are these parameters actually arrays or variables, local variables or global variables? What are they? So the whole profile of the parameters is mentioned in that header. And also the return type. What is the return type? Like, for example, if you look here, you will see that here I have these different languages like Fortran, Ada, Scala, and C. I have headers examples. This is in Fortran. We start with subroutine, and this is the name of the subprogram, and this is parameter list. Sometimes, most of the time, this parameter list is optional, by the way. And if you have more than one parameter, you separate them with commas most of the time. In some languages, you separate them with semicolons. In Ada, we have to start with the where procedure, and then the name of that function, and then parameter list as well. And in Scala, you start with def, and then the name of the function, then parameters, and then with equal whatever statements comes after that. In C, you can have a return type void, which means this function does not return any value, or you can have int for integer, or char for character, or double for double floating point, and the name of the function, then the parameter list. So the list of parameters here could be arrays, could be structures, or could be any local variables. So basic definitions also, we're going to talk about the declaration side on the function. Function declaration, for example, in C and C++, sometimes are called prototype, because in C or C++ examples, if I have a C or C++ example, I would show you. Let me search for any example in C or C++ to show you an example of I have this example, so I can show you a function declaration, which is most of the time is called prototype. يعني function declaration is same like function prototype. So here, let me just create a small example. If I have example opened, that will help me. Yeah, I have example here, but I'm gonna modify this example to show you just how this function prototype look like. So for example, let me create a small function here. All right, a small function. Call it sum, which accept n1 and n2 as parameters. Okay. All right. So here, and then this return n1 plus n2. Right. All right. This is my function. Okay. My function returns n1 and n2. This is my main function that calls this function. Okay. This sum function. So for example, I have these two integers like int n1 equal 3, for example, and int n2 equal 6, for example. All right. So now what happens is that I'm going to pass these two parameters here, which is both of them are integers. The order is very important here. Now this is the function definition, the whole thing. This is the header we talked about earlier, but you need to put it up there as declaration, function declaration. This is called declaration. Okay, declaration, or in other words, we call it what? Prototype, function prototype. And this is the function header. But the whole thing here is called definition. All right, definition. So now if I'd like to actually execute this function, I can call it. Look, how am I going to call it? I'm going to call it by using cout statement to display the value of sum, which is going to be 9, right? It's going to be 9 for n1 and n2. Of course, I can have default values. And I'm going to show you in a minute how this one works. Let me just try to see if I can execute this one and show you the result of this. This one is showing the result right now. All right, it's a little bit slow, but it should come here. N1 and N2 should be okay. 9. This is the value 9, right? Look, you can see that. All right. So now I can actually execute them with default values. So I don't need this n1 and n2. I need any other values, right? Just write any other values. Okay. So here, for example, I would like to put like 4, and here I would like to put 8. All right. All right. Now we can actually execute this one and see how the function reacts to this. This one should display display 12. Look at it here, 12 instead of 9, even though we have parameters listed. So this example shows something. Shows that this is the function prototype. If I don't have this function prototype, my program sometimes will give you a problem. Look, it means it says here sum was not declared in this scope. I have to declare it. That's why I said this is declaration part. This is declaration or prototype. Now, when I actually, let me change this one 4 and 1 and see to just prove it to you that now this is no problem. It works. It will give me 5. 5 here, right? Look at it. So simply, in this example, I would like to reiterate that the function declaration in C and C++ are called prototype. So a subprogram declaration provides the protocol, but not the body of the subprogram. And it has nothing to do with the body of this program. It's only the header is enough. The header, but the header should be the prototype should be exactly the header, and don't change anything on it. So, for example, if this is, for example, double and this one has to be double, otherwise it will create an issue, and it says that there is ambiguity in the declaration of this, because now the data type is different, right? This is double and this is integer, so it has to be of the same type. Also, a formal parameter is a dummy variable listed in the subprogram header and used in the subprogram. This is true because look, these are parameters, isn't it? What are the parameters? Parameters are local variables that are passed from one function to another. So I'm passing them from this function, from this main into this function sum. So these are called formal parameters here. This is for formal parameters. But when they are passed inside here, they are called actual parameters, because the actual parameters could be the same values here or could be different values. So if we refer to these concepts, the formal parameters is a variable listed in the subprogram header, as in this example, in the subprogram header. But the actual parameter represents the value, or of course the address, if you have the address of the variable used in this subprograms statement. So in this example, I have the value, which is 4 and 1. But also you can have the names of these. By the way, these formal parameters could be different names. And here, for example, I can use, instead of N1, I can use G1 and G2, different names. It doesn't have to be the same, given that you change also this one in that prototype. There is no problem at all with this, given that you change this to G also in the return statement. So here, leave them N1 and N1, and change this one, make it, for example, 7, and this one 9, and here put N1 and N2. All right. So this one, simply I would say the parameter, the actual parameter, they can have different names, but the actual parameters, they should stick to the same name. Yeah, should just change this one to integer, because I changed it earlier. I forgot to remove to change it to integer, but it will not create a problem. It will work, giving me 16, which is the 7 plus 7 plus 9 in this regard. This example simply shows you that the formal parameters, which are in the function header, can be changed to different names, while the actual parameters stay the same as the names of those local variables that have been passed from that function to this function, or the values. We talk about actual and formal parameter correspondence in the positional. The position, in the binding of actual parameters, they have to watch that position. So the first actual parameter is bound to the first formal parameter, and so forth. In this way, it's going to be safe and effective. And for example, here, if I have N1 always will be 7, and N2 will be what? Will be 9. Because if this one is a subtraction like that, if it is a subtraction, not an addition, what is going to happen in this case? Let me just run it and show you. So it's going to be actually subtracting what from what? Subtracting G1 minus G2, which in this case, it will take that, 7 minus 9 in the order that it has been listed. But this one is going to be different if I put here, for example, N2 first and N1 second. So the first number will be second and the second number will be first. In this case, it will give me this positive 2 instead of negative 2. So simply it says in the positional dividing of actual parameters to formal parameters is by position. That means the first actual parameter is bound to the first formal parameter, and so forth. The second one to the second one, the third one to the third one. Because sometimes, guys, these values are not all of the same type. So, for example, this is an integer, but this is not a second one is character, for example, char. And the third one, there is a third one here, for example, double, G3, for example. And there is a fourth one, which is, say, float, G4, and so on. So we have to be careful that the position that the first one bound to the first one, the second one bound to the second one, the third one bound to the third one, and so on, so that we have to make it accurate and we don't get into confusion for this programs. Also, the name of the formal parameter to which an actual parameter is to be bound is specified with these actual parameters. So you can use the actual names, or you can use different names I have specified earlier. Because this, one of the advantages, these parameters can appear in any order. But given that this order has to be bound to the actual parameter that you are listing in the function when you call it, or in the subprogram when you execute it within another program. But one of the disadvantages is that the user must know the formal parameters names. So if you don't know the names, then you can actually get into the trap of having some issues. In certain languages like C++, Python, Ruby, PHP, you know, these formal parameters can have default values, but if no actual parameters is passed, then you can have default values. So for example, I can put zeros sometimes is passed as by default if there is no value has been included when you call these subprograms. In C++, default parameters must appear last, because parameters are positionally associated. So there is no keyword parameters. That means if you have a default parameter, don't put it in the beginning, put it at the end. Exhaust all your parameter list with the actual parameter list. But if you have a default one and you would like to put it here, for example, you have a third one and you don't have a value for it, you can put a default value like 0, for example. So for example, here, if you have like int G3 like that, and then you don't have any corresponding formal parameter for this one, you can put a default value like this 0, so that this G3 is going to be this 3. But the number of the actual parameter should equal the number of actual parameter. If you have 3 here, you should have 3 here. That's why sometimes you need these default values to make that correspondence to the calling function. In C#, methods can accept a variable number of parameters as long as they are of the same type. In C#, any number can be used in the list, but this has to be of the same type. They're all integers, or all characters, or all string, or all double, or all float, or all bool data type. As long as the same type, the corresponding formal parameters is an array preceded by params keyword. This example here is actually in C or C++, where you have the data type. This is a retained data type for the function called nums, with these 4 different actual parameter list. In Ruby, the actual parameters are sent as elements of the hash literals, a group of hash literals like this, hash literals like that. By the way, in C++ also, you have an option to leave this list here without any without any names, as long as with the same type. And if they are the same type, here these two integers, خلاص, these should be integers. But you see here, I remove the names. There is no n1 and n2. But this also works. Let me prove that it is it's working. So here I have 10, and I have 20 here for this one, and I have two parameters with n1 and n2. But look, in the function declaration, I don't have any. But I don't have names for these parameters. But I have what? I have the data type. So the data type is compatible with the data type that has been listed in the function header. So here I can execute this one. This will give me 10, which is the value of 20 minus 10, and n2 minus n1 according to this example. All right. So in Ruby, the actual parameters are hashes. And you just, instead of leaving them like that, you put a bunch of hashes here inside this function. So that means the number of these parameters are important, and the number and their data type, but the names themselves are not a big deal in this Ruby programming language. In Python, the actual parameter list is a list of values, and the corresponding formal parameters is the name of name with an asterisk. Yani the name with an asterisk, which is, it looks like a pointer, so preceded by an asterisk, which is like a star, like that, you know, which is similar to the pointers in C and C++. That is in Python. So the actual is a list of values, but the formal is a name with an asterisk. That means the actual here is the name itself, like G1 and G2 without asterisk. But here, or the values. So for example, if I put here, for example, 33 and 44, for example. All right, no problem with that. But here, it should be the asterisk. So these are values or names, but these are the names preceded with the name preceded with an asterisk. Okay, let me explain very important concepts here in regard to subprograms, which is these two categories of subprogram called procedures and functions. Procedures are collection of statements that define parameterized computations, and functions resembles these procedures but are semantically modeled on mathematical format. So what happens is that a function is created to return a specific value. All right. And a function can be actually created to return a value and can be executed or called within different perspectives. While a procedure is this statement that defines specific subprograms. So you can execute a function inside a procedure, but you cannot execute a procedure inside a function. In practice, functions have some side effects, which is some what's called some design issues, like what is the function, local variables domains, what are the parameter list, how this function is called, how is it executed? Is it executed in a select statement, for example, in SQL, or in a procedure or a package or something like that? Let me just give some examples of this using functions and procedures from this list here. For example, I have I have this example for a function. I would like to create a function here. This function is easy for you to understand. Let me just make this picture big for you. This function, I said create or replace function. So I would like to create a function degree Fahrenheit to degree centigrade. And I would like to convert a degree Fahrenheit to degree centigrade. Here, what's my parameter? My parameter is degree Fahrenheit. And I would like to pass degree Fahrenheit as a number. So I use in here number. Number is my parameter. Okay, so I would like to pass in a degree Fahrenheit and get a degree centigrade. Yeah, and if I pass 100, I get 37.78 and so on. The return type of this one is a number or integer. Yani. And also I have a data type here, number for the degree centigrade. This is my program here, begins here in the function. But this is two statements, only two statements inside my function, which is I assign degree centigrade, which is this local variable, to this formula. The formula is 5 divided by 9, multiplied by the degree Fahrenheit, which could be any number that I will pass later when I execute this function, minus 32. So this is the formula to convert, okay? And then I retain a value. What's the return a value? I retain this degree centigrade, which is going to be calculated by this statement. And then end. You can end this function by its name, which is degree Fahrenheit to degree centigrade. Okay. So here I can create the name, make it smaller. DFC. Okay. Let us just call it DFC, degree Fahrenheit centigrade. And here I would like to end it as DFC. So the function name is called DFC. All right. So for simplicity, let me create it right here. I would like to create this function. This is a little bit slow, but it will create this function, and we say function created. What is the function? The function is DFC. Right, good. So now the function is created, but how do I execute it? For example, in this P procedural language, this is procedural language. I can use select statement, normal, like I do select in a table. Select what? Select DFC 100 from dual. Dual is a dummy table where I can use to actually select values or make some mathematical calculation. So give me this value. I can use round here, round yani round it to nearest 2 decimal places, like that, for example. So that it can give me a smaller value, which is 37.78. Good. But I can use any value. Like if I would like to see 100, I would like to see 32. What is 32? Which is the freezing degree in Fahrenheit. It should be 0, right? In degree centigrade, which is 0. Here it is. So this is my function. But how do, because here I was talking about the procedure, collection of statements that define parameterized computation. So here I would like to create that procedure to do this execution of this function that I have just created, because I can create a procedure, give it any name, like create or replace a procedure, call it temp, for example, as a name. Okay, as declare as instead of declare as, this is my local variable. So okay, degree F is the name of the variable. It is this type is number. Begin. I would like to display this this function. I call it now DFC. Remember, here I can put any. Let me put 96, for example, as and round to the 2 decimal places. All right. So let me just execute this procedure. So I created a procedure with what? With a value. What is this value? This is what we call actual parameter. Remember, what is the formal parameter? The formal parameter was degree Fahrenheit there in the function. But this is my actual parameter value, which is in most programming language we call it argument. And you know, this is my function. I can actually create, I can execute this function while using begin. Begin what? Begin and then temp, which is I execute. This is how to call that function, and then end. Just execute this function and end. Nothing, because this function is this procedure has been created with 96 on it, right? So when I execute it, I will get 35.56. It says the centigrade degree is 55.56. You know, if I would like to change it with different values, I could have changed it with different values, you know, but in that value has been actually executed within that parameter. Now it's giving me a mistake. Why? Because the wrong number of types of arguments called in temp, because there I have already called it with a value in that function. So if I'd like to change that parameter, I have to change it here from the procedure when I create that procedure. So for example, here, if I would like to call this one, change it to, for example, to 99. For example, I have to change this one here, and then after I do this, I come here and execute this program again without any parameter value. It's going to be now 37.22, which is the 99 degree Fahrenheit, equivalent to 37.22 degrees centigrade. So this is basically the difference between procedures and functions in regard to, you know, parameters, formal parameters and actual parameters, and how we can execute function within the procedures. So some design issues for these subprograms, like, you know, we can talk about local variables. Are they static or dynamic? Also have a lot of question about can these subprograms, you know, appear in other subprograms definition, and can we have a nested subprograms? I mean, this question is not to be answered. This question is concerns or the design issues for subprograms. When you are creating them, you're going to have to answer a lot of questions about them. What parameters passing methods are provided? Are these parameters checked, type check, or not type check? If these subprograms can be passed as parameters, as subprograms can be nested, what is the reference environment of the pass variables or subprograms? Are these, you know, functional? They have functional side effects in them. Are they allowed or not? What type of values can be retained by a function type? I mean, are they integers? Are they characters? Are they float? How many values can be retained from a function? Is it one value or no value or multiple values? Can this subprogram be overloaded? That means subprogram can have the same value, the same name of these programs. Yani, we call it overloaded functions or overloaded subprograms when we have you know, many functions with the same name. And so on. There is a lot of also if the language, a specific language, and a programming language that allows nested programs, closure supported or not. This is a lot of design issues for subprogram that we need to think about. Also, we need to talk about local variables referencing, yani the local referencing environment, which is can be stacked dynamic or could be static. A stack dynamic variable is one that is bound to an address on the stack, which is dynamically, yani during runtime, is allocated for that specific purpose. So it must be, it may also be unbound during runtime, and memory cell deallocated when it is run. Yani the memory will be emptied or vacated during the execution to allow for new values to be used. The advantage is support for recursion, multiple execution. Also, the storage for local is shared among some subprograms. Yani the space provided for these subprograms can be distributed among other subprograms, specifically the nested ones. But also there's some disadvantage, which is, you know, deallocation process could be a challenge, and also the initialization time for these values, specifically when you talk about, arrays or structures. Subprograms cannot be history sensitive. That means they might not refer back to the same allocation of these variables. There might be some deallocation, or the location or the references or the memory addresses that has been deallocated for specific subprograms might not be allocated for the same programs when they are recursed, when they are actually executed again and again, specifically in terms of re-execution or multiple execution of subprograms or functions. So the local variables can be also static. A static local variable is different from a local variable. A local variable is initialized only once. Okay, only once. No matter how many times the function that in which it resides is called, and no matter how many times the value is returned and accessible through these calls of the function. The advantage and disadvantage of this is specifically opposite of this stack dynamic local variables in terms of allocation and disallocation. So simply the advantage of these local variables, they are static, so they actually retain their actual values and they cannot be changed during the program processing, no matter how many times they are called. In most languages, the local variables are stack dynamic. In C-based language like C and C++, local variables are by default stack dynamic, and can be also declared by the word static. And static, if you declare them by static class, they become non-dynamic. They'll be static. Their value will be fixed. The methods of C++ in Java and Python and C# only have stack dynamic locals, but in C or PHP, that they can have other static environment. There is what we call pass by value. We call it in mode, pass by value, of course, and we have pass by result, we have pass by reference, but pass by value means the value of the actual parameter is used, the value of the actual parameter is used to initialize the corresponding form of parameter, like the example here. So if you have here, we used 10 and 10, not 33, 33, the actual value that has been assigned in this program. So normally implemented by copying the same value. So can be implemented by transmitting access path, but not recommended access path. Access path means the location, because sometimes the location can be changed during the program processing, and specifically if you are doing some mathematical operations and you have a lot of variables declared. These memory locations and addresses are used specifically for these variables that are dynamic. They can be deallocated for other variable values. So they can be used to store other values, and this is the danger of using this kind of copying. I mean, this kind of what we call access path. But the copying of the value, there is no problem at all. Because the disadvantage here, if by access method, if you use by access method, you have to use that variable as write protected. Write protected means change the permission of these variables to make them not accessible or cannot be changed in a way. This is usually used in language like Perl, for example. When you have access, it costs more addressing because it needs more memory space to swap values sometimes. We have pass by result. We call it out mode. When a parameter is passed by result, no value is transmitted to the subprograms. The corresponding formal parameter acts as a local variable. So it acts like a local variable. So the value is transmitted to the caller, to the function that makes the call. Then the control will return back to the caller by physical move. Physical move means actual copying of the value. This one, of course, requires more storage location and also a method for copying operation. And it has some potential problems because whenever you have this formal parameters is copied back, it will compute the address of that location, and then it will use these values in the order they are listed. So if the order they are listed has been changed in another subprogram definition, then there might be some accuracy problems in these subprograms results. Pass by value or by result. By value result, we call it in-out mode. Because by value result, we call it by value result. Pass by value result. A combination of pass by value and pass by result. And sometimes it's called pass by copy. In this case, the formal parameters have local storage. The pass by value result is actually a result of a specific call is used as the formal parameter, which is similar to the copying of the value itself. But the difference here is that the value has already been used in a processing before it is being copied. So we call it value result. Pass by reference, which is access path. Reference means the address, memory address in which the value resides. It's called by sharing also. The location of the value where it resides. It doesn't here because here if you look at this, if I used here N1 and N2, that means I am actually copying the address of where these variables resides. I don't know where they reside. They're residing somewhere in the system. So I am actually passing by reference. Here, if I put values, actual values, then this is called pass by value. So the advantage is passing process is efficient. There is no copying and no duplication of storage. That means passing by reference is more efficient because it will go directly to the location where the value resides. So if you have values being stored in these memory locations, then pass by reference will be more accurate because it will reference back to the location where these values or these variables are residing. But it has some disadvantage because it will be slower. Definitely is slower than pass by value. Pass by value because the value is given as a parameter, as argument, which is actual parameter. Straight, it will work without any delay. But in pass by sharing or by address or by reference, there is a problem of slowness. Although it's not going to be very slow, but it is not as fast as pass by value. Okay. Also, there is some potential for unwanted side effects collision, which is we call it unwanted alias access. Also, unwanted alias access, aliases is another name for the variable. So if the name of the variable has been changed during the program processing, then it might refer to the wrong location where that value resides. And for example, you have n1, and then you change this n1, you renamed it as, for example, n something, n_1, for example. So yeah, definitely you are changing the name of the location of that variable. So also, again, we say you have to be careful on using this pass by reference. You have to use the actual name where this variable is declared. Pass by reference also, it has another issue. Can the pass reference be changed in the called program? In most programming language, no, cannot. In C, it is possible to change, this reference. But in some other language, like Pascal, for example, there are some addresses that are implicitly dereferenced, which prevents such change. You cannot change them once they are assigned. They are stuck with that name. You cannot change that name from them during the program execution. So that's why I said pass by reference needs some sort of attention in when you are writing the code in these programs, because you need to know whether you are using C or C++ or using Pascal, or which programming language you are using, because the usage of the language determine the pass method. Is it pass by value, or by reference, or pass by value result? There is also pass by name, by the way, which is called in-out also mode. This is a textual substitution, which is the name of the actual parameter is used here. So it allows for some flexibility. In I don't know which language that it uses this, but I think that some C-based languages can use this pass by name. Because its implementation needs some sort of referencing environment of the caller. That is, the caller is passed with the parameter, so the actual parameter address can be calculated, specifically when using mathematical operations, complicated mathematical operation that requires heavy use of different data types in the same mathematical processing. In most languages, parameter communication takes place through the runtime stack. The communication, we call the communication, parameter communication, the communication between parameters, specifically especially in what we call mathematical operations. It takes place through this runtime stack, allocation, deallocation. During the data entry, for example, during execution of these applications. And pass by reference is the simplest to implement. Only the address is placed in the stack, the address of the variable, but it has this advantage, as I mentioned before, which is referred to the number of times these subprograms are used, and also the recursion of these subprograms. It also depends on the language that we are using for that respect. And to implement parameter passing method, this figure, shows the main function code here with some, actual parameters w, x, y, and z. And here the function called sub, it has parameters chain like here, if you can see that the sub has A, B, C, and D, while in main it has W, X, Y, and Z. So the function header for this one is void, so it doesn't return any value. And the function call in main, the function main calls what? Calls this sub. So it pass W, for example, it can pass W by value, and pass X by result, and pass Y by value result, and pass Z by reference. In this respect, you can see from the start that the value of A is reference to the A here in this function sub. So, and then in the same function we have another parameter which is X. X here is by result. So at the end the value of B is assigned to B. The value of B is assigned to B, which is now A is actually being pointed to by B. And in Y, which because Y is passed by value result, first at the start, you know, the value of C is reference to the C in the subfunction and assigned. Then once it is reference to C, it is assigned to C and come back in the stack. Stack is actually the intermediate process between the caller and the call function. So here we would say that it is assigned back to the value of C, and in the end it will come back to replace or to stand on the place of Y. And at the last one, which is this you know, by reference, which is the Z1, the Z because it is by reference. At the start, you know, the address of this D is referring to the D element here in the code. And then what happens is that when it comes back with the address of that you know, parameter, which is the address of what? The address of D. The address of D simply it refers to the place where the parameter D is containing or is reference. Let me give you an example here. For example, you imagine a plane ready to take off, okay, with all passengers. Every seat has a passenger sitting there and putting their seat belt, ready to depart, okay, ready to fly. And you know, these passengers, everyone has a specific seat number. 33A, 33B, 33C, 33D, 34A, 34D, and so on. All until, like, for example, there's 300 passengers in this plane. Just imagine that for a second. When we talk about the pass by value, we mean the person who is sitting in that seat. Assume that the name of that person is John, right? So we can refer to that person by his name, and would like, for example, John Edward. Somebody came in the plane before it departs and he said, I need a passenger with the name John Edward to stand up, come down right now out of the plane, right? So now that is the value why you're sitting in that seat. Assume that seat is 38A. Then he went out for a reason, emergency reason or security reason. After a few minutes, somebody else came and he said, I need the passenger who is sitting in seat number 49C to come down. So here he didn't mention any name, right? He mentioned only the seat number. So that guy who knows that he is sitting on that 49C, it will come down. Because now he's not referring to the name, right? He's not referring to the value. He's referring to the place, to the location, to the address where this passenger is sitting, which is seat number. Because the seat number, every boarding pass is printed, has a print name of the passenger. I mean the seat number for that passenger. So they know that this person is actually sitting on that seat. So they came and called him out. This explains the difference between value and reference. I would like to stop here for this video so that it doesn't get bigger and heavier, and then I will complete this chapter in a different video.